Thanks for the opportunity to join you and talk about climate change. I think my charge is to talk about climate change, focusing here in Maine, and a little bit about things that are happening and a way forward, but to try and stick to my time limits in doing that. And so I'm get started. This little GIF that's the first slide is something to look at when I'm babbling on about where I come from or something like that. But obviously, it's a record of the monthly temperatures for the planet, put together by Ed Hawkins, University of Reading in England. That's visualizing the continuously warming annual temperatures that we've seen around the planet. Heading towards those 1.5 and 2 degree markers that I'll talk more about in a minute. We're going to talk about climate change here tonight. 2020 is obviously a remarkable year to be talking about a lot of different things, and certainly climate change. I can't help but when the comments were a little bit earlier, I didn't realize it would be this momentous, since I just learned that Hildy is retiring. So that's a particular noteworthy marker in time. And good luck with all of that, Hildy. But on a more serious note, we don't need much more evidence than the things that we've seen going by on a lot of levels. Obviously, the racial unrest in society and the economic downturn driven by the pandemic that we're obviously all still living through, as well as climate change. And so this slide's just a little eye candy to remind us what we've seen over the year. We've watched these mega fires in the West. Over 5 million acres have burned, over 35 people have lost their lives. That image up there, I'm pretty sure that image up here is Paradise, California. And we're kind of getting used to seeing entire communities that are leveled to ashes. We've had a lot of hurricanes racing across the Atlantic. I think we're up to Theta today. And we now broke the record from 2005. So we're up to 29 storms and counting. We had flooding in the Midwest, and particularly in the earlier in the year. We keep seeing stories about ice shelves calving off of glaciers, drought, both in the Western United States, but obviously here in Maine, that you guys know all about, and to some extent still persisting. We keep coming up with new, meteorologists knew all these things, bombogenesis and things like that. This year we learned about derechos, which are these lines of storms that raced across the plains. And I just saw, I think, a piece in the New York Times or someplace that today that said that Iowa alone had $1.4 billion worth of damages from those storms when they came through earlier in the summer. And we continue to have places on the planet that are increasingly uninhabitable. And so this is Death Valley earlier this year with a park ranger and poor woman wearing a mask on a day that's 129 degrees. I hope she was there very briefly for the picture, but obviously those are compelling and uninhabitable temperatures, and there's many areas in the world that are experiencing that more frequently and to a greater extent. So there's lots of these extreme events that go along with the trends of climate. And this is the stuff that we notice and that the news carries. But there's so many other trends, and we'll talk about a few of them, that persist and are chronic, and in almost all cases are accelerating. So what do we know about climate change? And we see it in the news, and obviously it's become part of the politics of the election this year and at the presidential level, finally. Well, most of what we know that we hear about on the news most often comes from these folks, the Intergovernmental Panel on Climate Change. I suspect most of you are familiar with it or have heard the name of the organization affiliated with the United Nations. And this group of hundreds of scientists are gathered together from around the world in order to assess the status of the climate. Began in 1990, and they issue new reports roughly every 5 or 6 years. They're usually a sequence of reports, and these images on this slide are typically the first report, which is the physical science basis that's telling us how the climate's changing. And then there's other reports having to do with adaptation, mitigation, and so forth. The most recent reports are 2018 or 2013 for IPCC. 2018 is for the National Climate Assessment. In 2015, we had the Paris Convention and the Paris Accord that was signed by nations around the world at the time, including the United States. And it agreed to meet certain criteria for greenhouse gas emissions reductions. They also requested of the IPCC to do this last report in this slide, which is not part of the typical sequence, global warming of 1.5 degrees centigrade, in order to understand the consequences of the planet warming to that extent or to that degree. And that's why you saw on Ed Hawkins' slide that I started with, this 1.5 degree ring as sort of a boundary condition that we want to not go past, because, you know, increasingly bad things happen, higher likelihood of tipping points. And then they also asked for an assessment to 2 degrees to determine, you know, what the consequence was for that additional increment of warming relative to damages to the planet. There were also 2 other reports that were issued in the same window of time, very comprehensive reports. I'm not talking about them here tonight. One had to do with land use, which would be of a lot of interest to all of you. And you can download all of these from the IPCC website. And the other has to do with oceans and the cryosphere. So oceans and all of the frozen areas around the planet. But this is the one that's received the most attention, and appropriately so. This is the one that talked about the reality that we have warmed about 1 degree centigrade so far. These are planetary scale data. And when this was issued, it was showing that about 1 degree of warming has taken place by about 2017. This is where they stated that in order to bend the curve, and we know a lot more now about bending curves than we did when this came out, but in order to bend the curve to keep at or close to 1.5 degrees, greenhouse gas emissions needed to decline by about 45% by 2030, and to be reach net zero by 2050. And so we needed to have very dramatic declines starting immediately in order to avoid this trajectory. This trajectory is the one that we're on. And the one that we're on is right now headed to blow past 1.5 degrees without any problem. In order to achieve that level of warming, in other words, to level it off, this is a plot of greenhouse gas emissions, or CO2 emissions in this case, which is the dominant greenhouse gas. And so these are the historical record of what we're on, and this was 2017, and we're still going up. And this is the kind of change in trajectory of emissions that we need in order to achieve the goals of keeping under the 1.5 degrees Fahrenheit. And so you hear in the news talking about, we have, you know, when this came out, we have 12 years left. Now we have 10 years left in order to solve climate change. Well, that's not really true. We needed to start a while ago in order to solve climate change. And we needed to start tomorrow morning in order to meet these kinds of aggressive targets by 2045 and 2050. And to no one's surprise, of course, we continue to break records of increasing levels of emissions every year. And so we haven't really bent the curve at all in that regard. And in 2019, it was no different. And in 2020, we'll also exceed that limit, even although not by quite as much because of COVID and the declines that we saw temporarily during this pandemic. So that's what we know about it from a planetary basis. Some of you that may have seen me give a talk before, almost regardless of the topic, I love this slide because it's got all these wonderful pictures of Maine. And I use it to make the point that, what about Maine? So that's what's happening on the planet. We can see what's happening on the, at the national level. But a lot of these decisions and a lot of our response to it, a lot of people's response to climate change is local. It's what's happening in my backyard. Sure, there can be these storms out west, or it can be warming Gulf or warming ocean waters in the Pacific. But we all have a lot of stuff to deal with, and that can fade. So I was really interested in better defining what we know here in our backyard. And you can, take a look at that image, and sure, there's lots of places that have lots of states that have trees and agriculture and water. And but when you look at that image, potatoes and lobsters and Paul Bunyan and Mount Katahdin and, Portland Harbor, of course, that's Maine. And there's unique aspects to all of that. And everyone here, I think, fully appreciates that. So how is climate change happening in Maine, and what are the implications for who we are in the state? And so that prompted a group of us to do an assessment of climate change in Maine back in the late 2000s. We issued this first report, Maine's Climate Future, 2009, ostensibly at the request of Governor Baldacci at the time. And we did an update in 2015, an update in 2020. I'm going to show you some of the data from particularly the last two that can very quickly give you an idea of what are the data for climate change here in Maine, and a little bit about what we expect going forward. And so I like to do that with what I call my climate dashboard. And the middle column of the dashboard. And so these are a handful of indicators relative to climate change. This is the what we've experienced over the last, actually over 100 years, but and then this is what were projections from our recent reports, what we might expect but in the near future over the next few decades. The importance of this column is it's the real deal. These are measured, observed, it's not speculated. They're modeled, but in the context of if you've got 3 stations and a gap in between, there was an average, you average the 3 stations that you have to come up with the gap in the middle. But it's all based on actual measured data. So it's unequivocal that these changes have taken place. To no one's surprise, it's gotten warmer. Over the last 100 years, we've seen about 3.2 degrees Fahrenheit in warming. This is the trace or the time series of warming. And so it's really noisy. Sometimes it's, as we all know, one year we're bombarded with snow, and the next year we have 15 snow melt events between January and the middle of February. And so there's lots of variability. Climate is not weather. Climate is the long-term trends in weather. And clearly, the trend is increasing. 3 degrees over the last 100 years, and we expect 1 to 3 degrees by 2050. We know that the 6 hottest years for the planet were the last 6 years, and so we're clearly in a trajectory of increasing temperatures. The warming has given us a longer growing season. Depending on what you do for a living, you can think about it as the growing season, the frost-free season, or you can think about the flip side of it, the winter season, getting less. But it's changed by about 2 weeks, a little more in the fall than in the spring, even though we focus more on the spring. And we expect that to continue with an additional 2 weeks by the middle of the century. Heat index days are on my chart. That's hot days and humid days, and the combination impacts us as humans, and that's what we call the heat index. Here in vacation land, we're known for not having too much of that. It's really pleasant most of the time. And we'll have more high heat index days, which have human health consequences, more of that in the coastal region. I won't say where we are now because we are all in our homes right now, but certainly in the coastal areas where the climate is warmer in that division, we're going to see more of those kinds of events. We've gotten more precipitation, and when I gave a climate talk 15 years ago, I'd maybe say that offhand because that's what the science predicted, but we wouldn't talk much about it. Now we talk a lot about it because a lot of people, that's what they've noticed. And the folks that would come 15 years ago, perhaps, and question the reality of climate change, now come to the discussions asking, what do we do about it? Because there's no question that this is different. We've seen significant changes since the year 2000, roughly 15% over the last 100 years, with more to come. And with the precipitation is a lot of variability in that precipitation. We're getting less winter, less snow, and there's lots of different metrics that we can use for winter. About 7% statewide over the last 100 years, and a lot more to come, 20 to 40%. This figure over here is the projected snowfall decline. And the three colors represent the actual official climate divisions in the state of Maine. We have three divisions recognized by the National Weather Service. The coastal division already is warmer, as we've already mentioned, and so it's closer to 32 degrees, and so a little bit more warming is more likely to put us over that line more frequently. So we're going to lose a lot of the snow and winter character of our seasons in coastal Maine as compared to the mountains and the interior, where we will lose less, but certainly how we recreate in that part of the world is really dependent on the character of winter. So it all becomes really important to a state like Maine. Ocean temperatures, you haven't been in Maine if you haven't heard somewhere that the Gulf of Maine is warming faster than 99% of the world's oceans. And this plot here is showing sort of the long term, and then you see these couple of lines. Again, another noisy squiggly line, but most recently we've seen rapid increases in the temperature of the Gulf of Maine. That's having profound impacts on fisheries and biology, and driving the migration of the centroid of lobster populations further north. Right now it's still in Maine, and so we're still catching a lot of them, but that's expected to decline. And we expect more warming to occur. Depending on a variety of scenarios that may unfold, it will vary quite a bit, but it is accelerating no matter which scenario you follow. And then sea level rise, in Maine, we've got 3,500 miles of coast, not counting the islands. And so sea level rise is a big deal for us. It's risen by about 0.6 feet over the last century, with a lot more to come, up to 3 feet, although I'm going to give you more recent projections, or more refined projections here in a couple minutes. So we see throughout plenty of evidence that this is the changing climate. This is not the extremes. This is the pattern of change in the climate system and a shifting in boundary conditions that is fundamentally changing who we are relative to how the climate impacts us on our daily lives. One thing that's not on my dashboard is ocean and coastal acidification, because we haven't really been measuring it that long. So we don't have these nice long time series. This is from the recent Maine Climate Council Science and Technical Subcommittee report. And I included here just to both point out that we do have this occurring in the Gulf of Maine, ocean and coastal acidification. This plot is showing you the atmospheric concentrations of CO2 that are going up, and probably a lot of you have seen that plot somewhere from Mauna Loa. This is the dissolved CO2 in ocean water that's tracking what's in the atmosphere. And if you dissolve CO2 in water, you acidify it. And so this is the declining pH as a result of the increasing CO2. That's called ocean acidification. That's occurring. And I often will say, if nothing else in the last plot chart was going on and all that was happening was this, we would have a global crisis on our hand. Coastal acidification is kind of a refinement of that. It is the acidification of waters near the coast instead of sort of deep blue ocean. It's the same thing to some extent, the CO2 dissolving in ocean water or creating an acidification, but it also is driven by runoff from our watersheds and things that you guys work a lot on that deliver pollutants to these coastal waters that also have an impact on acidifying the water column in many cases, combined with the CO2. So it's an even more complex. So when we talk about broadly ocean acidification, we're talking about all of it. And some of it we have some control over, like coastal acidification. All of it we have control over, but it's having to do with reducing greenhouse gas emissions throughout the planet. What about the future? Of course, that's a lot more challenging. So now we are talking about models and speculation. I'm going to show two indicators. One is the temperature itself. This is pretty much the same plot that we just saw at a more of a squashed scale and expressed as an anomaly, as a difference rather than the absolute temperature, but the shape of the curve is identical. And this is some modeling done by Sean Burkle, our state climatologist in the Climate Change Institute back at the university. That was part of a couple of our last reports. What it's showing is this is the historical temperature. And then depending on which scenario we follow relative to greenhouse gas emissions, we can end up expecting one of these different trajectories. To explain that a little bit more, these RCP stands for Representative Concentration Pathway. We don't really need to know that. This simply represents three scenarios that IPCC uses to project the future as a function of how much greenhouse gas we choose to emit. RCP 8.5 is the highest, worst case scenario in their modeling. RCP 4.5 is the middle of the road. RCP 2.6 is the low end. Sean took those same models and trajectories, but applied them to Maine specific data and gave us these trajectories where we will expect warming somewhere between 1 to 4 degrees by 2050 across this range, and potentially up to 10 degrees or more Fahrenheit by 2100. The difference here is 8.5 is the trajectory that we're on, and the scientific community is having a little debate among itself whether it's appropriate to call that business as usual. And I don't have any dogs in that fight. The reality is that our greenhouse gas emission rate is similar to 8.5. And so it is the trajectory pretty much that we're on. This is for modest levels of greenhouse gas emission reductions. And this is for pretty aggressive. This is a little bit like a little bit more actually than what we saw with the Paris Accord. But this would flatten the curve. The thing to take note is there's not much difference until we get to 2050. And so kind of no matter what we do, which doesn't help the politics of climate change, we're going to continue to warm for what's loaded into the pipeline right now until that point in time. But what happens after that diverges dramatically, and it has everything to do with what we do today relative to greenhouse gas emissions and every day between now and then. And so the big divergence comes later in this century that obviously our children and grandchildren and great-grandchildren are going to be living in that world. The other big one that impacts us here in Maine directly, all of them impact us directly, but that I'll talk about here is sea level rise. It has a profound impact. We live along, we're packed along the coast. That's where we live. We recreate. A lot of our industry takes place there. This is from the tide gauge at Portland. And on this scale, it's shown that increase, but it looks very shallow there. And then this is the trajectory for sea level rise going forward, depending, same deal, on the different scenarios that we choose relative to scenarios of greenhouse gas emissions that are driving the melting and the thermal expansion that gives us the sea level rise. This is the cover of the recent report from the Scientific and Technical Subcommittee of the Maine Climate Council that we'll talk about at the end, but this is 370 pages. You can download it, and it's a very comprehensive treatment of different aspects of climate change here in Maine. And rather than trying to interpret every line on this graph, I can summarize it by, and STS was charged with coming up with a specific and sort of detailed information on sea level rise more than any of the other indicators. The report and the subcommittee recommended that STS stands for Science and Technical Subcommittee. The Climate Council recommends that we consider to manage for 1.5 feet of sea level rise by 2050 and 3.9 feet by 2100. Then that's what you can see on the plot behind it. And additionally, to prepare to manage for 3 feet, essentially twice that, by 2050, and 8.8 feet by 2100. With some variability, of course, around each of those. And the prepare means there's a good reasons to think that's actually what we'll experience. The first one is guaranteed. That's what we're going to experience going forward. And all of the debates that I see in the scientific literature, and this isn't directly my area of science, but on the climate science part of me reads a lot of this stuff. There's ongoing debate about how much sea level rise, and most of the debate continues to be about that these kinds of projections are still too conservative to what we might experience. And so there's little question that we're in for very significant sea level rise. And of course, this is the chronic sea level rise. King tides and sunny day flooding becomes increasingly important. Storm surges are kind of what wipes us out. We've all watched Sandy and Katrina, so we know what that looks like. So what do we do about it? This is the sort of exciting part because there's lots of things that we can do about it. And we're not going to get into all of that tonight. We think about them as mitigation and adaptation, sort of two categories of activity. Mitigation being what we do to reduce greenhouse gas concentrations in the atmosphere. We can do that by stopping to emit. That'll slow down the concentrations. And we can do things that absorb, particularly CO2 from the atmosphere, that actually reduces directly the concentrations. We can do that in an engineering way, but we really don't want to do the engineering solutions if we can avoid it. Adaptation is what we do to respond to the reality of the changing climate that we're experiencing now and will continue to experience in an increasing manner. Sometimes mitigation is used in both categories, depending on which sort of discipline of science are talking about it. But generally within the climate science community, that's the way they're used. I purposely have a slide that looks like this because they're not mutually exclusive. There's all sorts of things that are both adaptation and mitigation all at once. And I can say to this group without reservation, building soil health is a wonderful example of what lives right in the middle of it. If we think about adaptation and mitigation, so how does all this stuff affect us? We could talk for, whole talks or whole classes on any one of these little items. This is just me dividing up the world the way I think about it into different sectors. We can talk about agriculture and forestry and human health and fisheries, communities, businesses, the economic standpoint, security, which is world security and military security. recreation and tourism, and there's others that I'm missing, and you can reshuffle the deck in different ways. But in each case, we could talk at length about how climate and the various climate indicators that we've talked about and others are impacting these sectors, and then what we can do about it, within those sectors to reduce contributions to greenhouse gases, and what we can do in those sectors to build resilience and to adapt, using science to minimize the consequences that are unfolding now and will only get worse. Why should we be hopeful? Time goes fast, but it was 2 or 3 years ago in a talk I was giving about climate change to a group of students at the university. And I forget what policy just got rolled back. Oh, I think it was about the time that that the administration was announcing withdrawal from the Paris Climate Accord. And students in the class, I think this was the big honors class climate symposium that we have every year. We had a very rich discussion, but there was a lot of them asking, why are we doing what we're doing? Why should we be hopeful? Why, it's a runaway train. And I gave, an answer that I would often give about, take it one day at a time and all of that type of thing. But I thought long and hard about what's the right answer? Why should we be hopeful? And I'm pretty hopeful. And I have 3 reasons that I give. One is society can change fast. We can go back in time and we can look at, if you think about it, and many of us have lived through transformations of computers and the internet, medical transformations, the stupidity of corn ethanol in the Midwest back in the 2000s. Haber-Bosch, some of you know what that is. That's the invention of fixing atmospheric nitrogen by a couple of German scientists back at the beginning of the last century that provided for the agricultural revolution and 2 out of 5 people on the planet. I've had this slide different colors at times, but for a while now, this year I've added, I don't have to convince anyone that we can change fast. The pandemic has transformed an entire planet in how we live and operate and communicate in ways that we can't wait to get back away from in some cases, but in some cases we'll never go back to where we were before in how we operate. But we can change fast once the right signals are put in place to move us in that direction. We know how to fix the problem. Since 1990, the first IPCC report, we knew what was causing it. We knew how to reduce greenhouse gas emissions. We also knew a lot about adaptation. And we knew, and we've learned as we've studied it, it's not a net cost. When we use science to inform the decisions that we make, time and again, we see that they are cost effective. That means for every dollar we put in to mitigate a pollutant, we study it and we realize, wow, society benefited many-fold if you put a financial, for the parts that you can put a dollar on, compared to what was invested. Using the best available knowledge to do that. So not every regulation is cost effective, or potential regulation is cost effective. So the argument that we can't afford to do it doesn't hold. And then cost-effective climate adaptation informed by science also is beneficial and not a net cost. And it's always more expensive to adapt after the fact. So, clean up after the storm is more expensive than putting in place science-informed adaptation before the fact. And so the science supports this. So I'm optimistic because we can change. We know what we need to do. What we need is sort of a few political and price point directives that move us in that direction. And there's different versions of this, but I like the phrase, the best way to predict the future is to create it. And so we have a lot of control over how we go forward in addressing this climate crisis. And so, what's happening here in Maine from the standpoint of, or continuing the issue of how we move forward, in June of 2019, Governor Mills signed into law the creation of Maine Climate Council, and with that, a set of targets that I'll talk about here in a minute to reduce greenhouse gas emissions, as well as come up with a climate action plan for the state. We had a climate action plan for mitigation back in 2004, and we had a preliminary plan in 2010 for adaptation. And sort of most stuff at the state level stopped at that point. Not really stopped. Agencies were still doing great work. But as far as a climate framework to do that work, nothing progressed beyond there. In 2019, this law was established, and it created the Climate Council. Here we go. Oh, and the council is 39 members that are a cross-section of state government and external entities. It's supported by 6 working groups: energy, transportation, buildings, et cetera, et cetera. Natural Working Lands is the group that dealt with farms and forests and conservation lands, which is probably the closest interest to this group. I'm going to say us because me too. And I sat with this group as well. And then the Science and Technical Subcommittee that was charged with pulling together the state of science issued that report and is involved in supporting the work of the various climate groups. This is the trajectory of Maine greenhouse gases going back to 1990. And you see we sort of reached a peak back in the 2000s. And then we've done pretty good on declining. A recession, the transition to natural gas all helped in creating this decline. We met our goals from the 2004 Climate Action Plan. And now the governor's, the goal is to limit emissions, gross greenhouse gas emissions, not net, gross. Below 1990 levels by 45% by 2030 and by 80% by 2050. And so these are really ambitious goals. This is not going to continue by itself without pretty dramatic changes in how we use energy. In addition, the governor had an executive order to reach net neutrality by 2045. Which you may have seen in the news when she went down to the United Nations and made this pronouncement. So this is the charge now for the Climate Action Plan to come up with a framework, a glide path, if you would, to achieve these goals relative to greenhouse gas emissions, and then a whole lot about investing in resilience. Just to give you a sense of where greenhouse gas emissions come from in the state of Maine, this is the breakdown. Over half comes from transportation, so we've got our work cut out for us. A lot of the emphasis is going to be on electrifying transportation to the extent possible, but obviously all things count. We all know about the issue with heating homes in Maine. We use a lot of foreign oil to do that. More than most, and we have to kick that habit. We're doing a really good job with heat pumps, and you're going to see a lot more installation of heat pumps going forward in order to achieve these goals. And so I want to just finish up with the natural working lands. All of these documents are on the Maine Climate Council website, and so I encourage you to check it out and download them and peruse them. This week, in fact, on Thursday, the Maine Climate Council's meeting to essentially, potentially approve the draft document that will be the final, that will turn into the final plan on December 1st. This is Ivan's version of sort of a broad summary of the kinds of things that are highlighted in the natural working lands recommendations that have been incorporated into the plan. A big one, don't mess up a good thing. We're here in Maine. It's 89% forested. We love our farms. We have a lot of high quality waters. And so the first charge, we're losing 10,000 acres a year to development from farms and forests. So the first charge is, can we slow that down? And let's not lose a good thing. You know, there's a lot of carbon standing out in that landscape, and there's twice as much underground. We want to keep those forests as working forests in most cases, and not lose them to development pressure. Invest in natural climate solutions. I suspect some of you are familiar with, maybe all of you are familiar with the term. It's kind of a new buzz term in the climate science arena, but it means using farms, forests, and wetlands, including blue carbon, coastal wetlands, et cetera, to help address the climate. We're not going to solve it. It's not a solution. We're not going to solve climate change with these. But we can contribute, and along the way, we can build a lot of resilience in our farms and our forests to the impacts of climate change, and which includes drought, heavy rains, warming temperatures, new pests and pathogens, and things that you folks know a lot about. So, you know, building soil health, I can't tell you how happy I am that in this latter part of my career, the whole world's running around talking about soil health all of a sudden. It's great, and it's really important. And I think there's going to be a lot of focus on investing. Carbon sequestration, building resilient ecosystems, enhancing technical assistance across the board, and of which I'm talking to professionals in this arena to help land managers to improve both their resilience and their contribution to these solutions. Increase climate education in schools so that it's not a novel environmental topic sort of in college only, but it's part of the way we live, because it is part of the way we live. And invest in monitoring and research. We're not going to know where we're going if we don't measure. We do have some of that, and certainly we do have some of that research. We need to do a better job and enhance the monitoring that supports it. So that's what we expect. I think you'll see in the climate action plan, with lots of details that go with it. So my last slide, closing thoughts. I would argue that if it feels like a pivotal moment in history this year, it's because it is. I really do think that because of the need to invest in recovery, invest in ourselves as relative to human health in our communities, and invest in addressing the climate crisis that's just going to get worse. There's no vaccine for the climate crisis. This is the vaccine for the climate crisis, a climate action plan. It's not going to go away, but it can get a lot worse than it needs to if we don't act. And so I think a lot of focus is going to be placed now in a lot of these issues which are interrelated. And so it's not these aren't in silos. We all know what we need to do in order to thrive. So we don't need to invent something in order to move forward on this. And yet every day we're learning more, and science is progressing and giving us more options in our solutions. Again, science-informed decision-making is not a net cost. So the argument, we've heard it before over and over again. I've been around for a long time. I heard it all about acid rain back in the late 1980s. If we limited sulfur and nitrogen from fossil fuel combustion, same stuff we're still fighting over here, it was going to ruin the American economy, and it didn't. It paid back 30-1. So, and the same is true for climate change and greenhouse gases. And business as usual is not an option because things are changing fast. Most changes are accelerating. And so anything that feels like we're being stationary about it means we're falling behind faster and faster every day. So with that, I'm done. Anyone has any questions? I probably ran over. So anyone have any questions? I'm happy to take them.
I had forgotten to say that people could write questions in the chat, and that we would, take them from there. But I think that we're a small enough group that if people do have questions, we could just
sure. Speak up.
Speak up, yeah. Unmute yourself.
I have a question, Ivan.
Yeah.
It's pretty easy to get really depressed by your presentation. I like why you had the slide, why be hopeful. And then the second bullet item, we know how to fix the problem. It's not a net cost. If that's really true, why, what are your thoughts on why we're not doing more?
Well, I'm going to give, this is, just me talking, but it's not a net cost to society. It may be a net cost to the oil companies. It too often is a net cost to those who are funding the lobbyists. But when we step back and say, okay, how much did it cost in order to implement these controls? And then who benefited? Or turn it around, how much did we save industry? And we're doing that right now. We talk about rolling back some of these you've probably all seen the articles of 100 environmental regulations that are rolled back, trying to be rolled back under the current administration. And yes, that'll save money for industry, but the industry is not going to pay when you take your child to the allergist because you've got, he or she's got more asthma, or they're not going to pay for sea level rise starting to or eating away at your property, and they're not going to pay for the drought in Maine in 2020, and we can go on down the line. So the distribution of the wealth is the issue, and who controls it, and that's been largely the problem. As I mentioned, it was the same thing with the acid rain. The lobbyists were, out in force, and 20 years later, we did the analysis and said, well, this is what it cost. A, it didn't put them out of business, that's for sure, despite the squawking. And B, when we look at the benefits, most of those analyses for air pollutants, you can just do on human health, the benefits to human health from the standpoint of cardiopulmonary disease and respiratory disease and mortality. The economists that do that can put dollars on that. I don't know how anyone can, but they can. Just that alone usually dominates the benefit. And then a lot of other aspects relative to ecological health, and then a lot of others that aspects and benefits that we don't know how to monetize, but they're still important to us. And those aren't even entered into the calculation. So, the naive answer, or not naive, but the overly simplified answer is politics. It's who has to pay initially, who's controlling how decisions are made in this country, and who's paying for the consequence of not acting to limit that pollutant, and in this case, the changing climate. And those aren't connected. If you put a price on carbon, you start to reverse that because now the consequence and the cost goes back to the source of production of the carbon. And I say this in the context of, I'm not carrying around a banner saying that all these companies are all evil, because we live off of what they produce. Our society survives on it. But I think by way of regulations and by way of the companies themselves, we've made conscious choices to not invest in improving the conditions, because the profitability for the company, not for you and me down on Main Street, and particularly for those that are lowest in the socioeconomic ladder. Those are the folks that typically pay the highest price for the pollutant concerns. So long answer, but anyway, that would be my answer.
Ivan, this is Nancy Prisk on
Hi.
South Island. Hi. I've missed being on campus, so this is incredible to have you here. Our community is functioning in a framework of about 30, 40 years ago, and climate change here, talking about why our beach is no longer a healthy place to be. It doesn't get heard. And yet we have, due to COVID, a significant influx of young families that have moved to the island. So we have some new energy behind this, and they're seeing it as a place that they'd like to see some changes take place. If you were to create an action plan for a small municipal government, what would be the key points we could start with and add to each year to create what we might need to be more mindful. I'll put it that way.
Yeah. Yeah, that's a great question and very interesting insight. That the whole in-migration relative to climate is a whole topic of fascination unto itself. So you hit on an area that's really interesting. I'm part of a group that has some funding that's working with a few Penobscot and Passamaquoddy Bay coastal communities in developing a climate action plan. I'm sort of there because I learned because the folks that I'm working with, they know what they're doing. They're social scientists and sort of marine scientists and community specialists. I think there's a lot we know, and a lot of this is taking place in some coastal communities here in Maine about developing an action plan, doing a sort of a checklist of vulnerabilities, and then determining, where to invest in first and the most cost-effective, again, approaches to doing that. I'm hopeful that pathways for finding those resources are going to be even easier as the Maine Climate Council's Climate Action Plan unfolds as we go forward in the next year and the years ahead. The Maine Department of Environmental Protection has a climate climate toolbox, I think, that a fellow named Nathan Robbins there has put together a lot of resources in order to lead people to information for various kinds of adaptation initiatives. And there's a lot about coastal communities. Sea Grant and a woman named Esperanza Stancioff that you may know. Okay, so if you know Esperanza, I see you smile. Just call Esperanza. You don't need me to answer it. So she's kind of one of the people leading this initiative and has been involved in that in coastal Maine. Nathan Robbins could give you some good pointers, and he's with the Department of Environmental Protection and great guy and a great resource. So there's kind of a template for how to do this. And when some of these groups are involved, they can come in and help communities with some of the community engagement to identify what's their priorities, and then sort of do the physical assessment of what's your priorities. Sea level rise is typically top of the heap relative to concerns and vulnerabilities, and then determining, what kinds of investments will provide what level of resilience. A whole bunch of towns, Damariscotta and South Portland and Portland have a big climate plan, and Belfast and Camden and Bar Harbor and a bunch of them have done or are engaged in this kind of process to look for models as well.
Ivan, that's really helpful. Thank you. I've been sitting here taking notes. Your work within the Native communities, that's part of my master's work actually is with Native communities. So I wasn't aware of that. Will there be reports coming out on that soon?
Soon. That's a good question. Within the next year, probably, yes. Esperanza will know better than me the timeline for working with those different communities. But yeah, soon. There's not a report out right now, though, that I can point you to. Otherwise,
that's excellent. I'll get in touch with Esperanza. Thank you very much.
Yeah, absolutely.
Thanks for being here.
Yeah, by all my pleasure.
So Ivan, I have a question or comment. You said it's obvious that things can change quickly. We can change quickly. We can adapt. Society can adapt and move fast when it needs to. But we've been talking about climate and for a long time, and society isn't acting fast. This pandemic hits people very individually and very closely. And it's hard not to, you watch the numbers of how many people in your community are getting sick, how many have gone to the hospital, et cetera, et cetera. And so most of us, do as the governor requests, and we wear masks and et cetera. But most of us haven't changed our behaviors that dramatically or drastically when it comes to climate change. I mean, myself included, I feel like I do what I can, but, I don't drive an electric car or, et cetera.
Yep.
So what do do you see that these reports from, that the Climate Council is going to result in initiatives that, are going to make us all change the way COVID has made us change?
Yeah, no, I totally hear you and agree to, to the context of what gives there. We haven't, as I said, it's 1990, we were having meetings and the big IPCC report came out, we knew what to do, et cetera. And it's a lot of years later and I've been, involved in a lot of it. So you're absolutely right. We haven't made a change. A couple points and why I have it in that slide, if you think that we're in a pivotal moment, we are. I think some of these things are converging. I think that part of our problem is the politics from the top down. I'll say in different talks and groups and with students, my personal philosophy is some people are just, beating themselves up because what you said, I'm not eating, whole grains and burning the candle only and driving an electric car, and sort of recriminating yourself. And I tell them, I don't have a big pickup truck. I have one of the little pickup trucks, but I drive a pickup truck because I can't do what I need to. We should do what we can do relative to our food choices, relative to our energy choices, relative to transportation. But we're not going to fix it individually. We need societal momentum in a direction to fix it. And we keep doing fits and starts, basically based on political cycles. I think COVID, there's nothing good about the pandemic, so it's hard to say the silver lining. I don't like that phrase. But the reality is the pandemic has shown us how vulnerable we are relative to a lot of aspects of our food systems. We're dumping milk and we're burying crops, and we have more people with food insecure in the state as we're dealing with this pandemic than ever before. Something's wrong with our systems to not be resilient to distributions, to provide local supplies. Holy crow, we live in the state of Maine and we were trying to buy toilet paper for 3 months. Something's fundamentally non-resilient with our systems that we can talk about it. And I'll sit in, at climate adaptation specialists webinars talking about how these pieces need to go together to build resilience. But until people can't get the food or can't buy a roll of toilet paper, will they change, or at least will they internalize it when these kinds of initiatives are presented? But we need bigger signals. And so, yeah, if you have an electric car, great. And I've sort of lusted at them, but they can't get into my research site and they can't get into our camp. So I'm still driving my little pickup truck. But when there's charging stations, every 5 miles on the highway, and I got a whole boatload of small pickup trucks that are electric that I can choose from, I'm going to be driving electric. So if we implement the kinds of systems that I think we're talking about implementing, putting in a lot more charging stations, using resources in order to do that, if particularly the federal government gives us a sort of a unified signal so that the auto companies start building the cars that they need to build. I mean, that's what they were looking for. They were looking for a consistent signal that this is where we're going, and so now you've got states and you've got nations saying no more internal combustion engines after, different dates. That kind of signal is going to have industry working for a solution, not against a solution. And depending on the politics, we've moved in the opposite direction. So I do think we're at a pivotal point where the pandemic has made some things real and visceral, from food systems to communications to our health systems to the internet. We talk about connectivity in rural Maine. and we've made some progress. Now we're really going to, I think, make some progress, because on the top of all these lists is internet access for everyone. That's the world that we live in, and that provides all sorts of benefits. It's not absolute. So someone that lives and works in, in northern Maine, and there's not a product that they can buy now that is A, satisfactory to do what they need to do relative to getting in and out and getting charged, and number B, that they can afford. And so we need a system that is not just for the elite who can invest in the latest and the newest, but rather the flip side of it, that makes it cost effective with incentives for people to get engaged in these new options that now are available. When they're available, I think we realize now as a society, every poll that you look at, 3/4 of the public believes, quote unquote, that climate change is a real problem. And, about half of them think it's affecting them. And about half of them, if I had a chance to buy them a cup of coffee and chat a bit, I could convince them that, oh, you mean that? Oh, if that's related to climate change, yeah. So I'm affected by that. A longer mud season, does that bug you? Yeah, that affects me. Well, that's one of the things of climate change. So, I completely agree. You hear these folks that are really eloquent in promoting carbon fee and dividend, which is a program that has gotten a lot of traction nationally, that puts a price on carbon and then puts it in a check to everyone, with the distribution balanced towards those at the lower end of the socioeconomic ladder, and the folks that it doesn't really matter are not the ones that are getting all of the money. There's a break point that would completely change the momentum of our economies. I'm not sure we're going to do it that way. We're going to do it a different way, but I am, very enthusiastic about the state of Maine now trying, after somewhat of a hiatus, trying to play catch up, and it is trying to play catch up. So they've crammed a lot into a year, and most of the sort of hard work is in front of us. But it's laying I think a path forward that we will see substantive changes in the electrification of transportation and in installations of heat exchangers and the reduction of fossil fuels. It's $4.5 billion a year we send out of state to fossil fuels. It's crazy. Let's invest that in ourselves. And I think we could be on the cusp of actually doing that. You're muted, Hildy. I don't disagree with anything you just said.
Yeah, no, well, thank you, Ivan. I thank you for your enthusiasm and your optimism. As Barry said, after, the depressing statistics, it's great to hear the other side. So thank you very much.
You're welcome.